What if I told you that all the visible matter in the universe, every star, galaxy, planet, and every atom inside your body makes up less than 5% of the entire universe? The rest is dark. Not just hard to see, but completely invisible. And it's secretly running the show of how everything works. Today we are talking about the two biggest mysteries in all of science: dark matter and dark energy. One is the invisible glue holding entire galaxies together, and the other is an energy that is tearing the universe apart. And together they make up roughly 95% of everything that exists. Let's start with dark matter. In the 1970s, astronomer Vera Rubin was measuring how fast stars orbit inside of spiral galaxies. According to Einstein and Newton, stars further from the center should orbit slower, just like planets in our solar system. But they didn't. The outer stars were flying around just as fast as the inner ones. The only way the math works is if there's a huge amount of invisible mass surrounding the galaxy. The invisible mass is what we call dark matter. It doesn't emit, absorb, or reflect visible light. It barely interacts with normal matter at all, except through gravity. And it causes light from distant galaxies to bend. It's called gravitational lensing. And by our current estimate, dark matter makes up 27% of all matter. The stuff that you can see and that we're made of makes up just 5%. Now the even weirder one: dark energy. In the late 1990s, two teams of astronomers were looking at distant exploding stars called a supernova. They were doing this to measure how the universe's expansion has changed over time. They expected gravity to be slowing everything down, except they found the opposite. The expansion is speeding up. Something is pushing space itself apart, and the push is getting stronger and stronger as time passes. We call that something dark energy, and it makes up 68% of everything that exists. And unlike dark matter, which seems to clump around galaxies, dark energy is seen absolutely everywhere. And Einstein actually predicted dark energy and the accelerated expansion of the universe long before we ever knew it. Now the thing is, we still don't know what either of them actually are. For dark matter, the leading idea is some type of particle that we don't know about that has weird interactions. For dark energy, the simplest explanation is Einstein's cosmological constant itself. It's an energy literally built into empty space itself. But new research hints that dark energy might not be constant at all. If that's true, the ultimate fate of the universe is a lot more uncertain and possibly scary. But here's the mind-blowing part. Without dark matter, galaxies probably wouldn't have been able to form. The early universe would have stayed too smooth. And without dark energy, the universe would actually probably end up collapsing rather than this racing expansion. And a lot of scientists are throwing everything at this stuff. One of the coolest things they do is they bury these detectors deep inside these mountains. This is so that normal cosmic particles can't reach them. And they wait for certain particles that don't interact with matter to come through and occasionally bump into these. Now the interesting thing is, if dark matter truly is a particle, we have yet to detect it at all on these particle colliders that we create. Now there are a few reasons for that. One would be if this particle is too massive, so we need a bigger particle accelerator, and the other is if we're not doing it often enough to actually get the particle. And for dark energy, we still pretty much don't know what it is. We only know what it does. Now this can sound scary, but remember, it's also exciting, because there was a time when we didn't understand what gravity was, and look at how we are with that now. So if you want to understand how such a tiny particle like dark matter can cause reactions like gravity, then go ahead and watch my string theory video. It will explain to you the different types of particles and how they cause interactions in our world. Thank you guys for watching, and remember, the universe will always be stranger than we once thought, and we're just barely beginning to realize it.